Okay, this is another UT Quest problems on forces and accelerated motion. This is another very ubiquitous physics problem. Two people on a frictionless surface pushing each other. Not very nice, but it's always a good problem. Okay, here we have Tracy and Tom, and they are pushing on each other. They're on roller skates, so we're going to assume that this is going to be frictionless. Okay, what I'm going to do then is this force of the push is going to be F net. Everything else is going to cancel out. Okay, this is a very typical third law problem. We have two objects, they're in contact. They're pushing each other. Now, most people tend to think, since Tom is bigger and more burly and more massive, he can push harder on Tracy than Tracy pushes on him, and that's incorrect. This force, according to Newton's third law, these are going to be equal and opposite forces. What is going to happen is, since Tracy has less mass, that force is going to give her a bigger an acceleration. Okay? So, what I need to know then is I need to do a little bit of kinematics first. What we need to do is we need to find out how fast Tracy is accelerating. Once I find out how fast she's accelerating, then I can find this force of push on her, which is going to be the same as the force of push on Tom. So let's take the mass of the girl and her acceleration. Okay, I know her V initial is equal to 0. And I know that she is pushed, or during this time of acceleration, she travels a certain known distance. Okay, so what I'm going to do is I'm going to back calculate her acceleration. So the acceleration of Tracy, the acceleration of the girl, is going to be V initial t plus 1/2 AT squared. Okay, and this t is going to be this contact time. While they're pushing, they'll be accelerating. Okay, so what this allows me to do then is this allows me to solve for the acceleration of the girl. This is given as the contact time. They are initially at rest, so this is 0. The distance that the girl travels is known. So what I'm after is this guy. When I have this, then I can plug it into Newton's second law. I'm given the mass, and now then I notice the force that must have been pushed on Tracy to make her accelerate at this rate. Okay, so that's one part of it that tells me about the force. And then this force pushing on Tracy has to be equal to this force pushing on Tom. Now the forces are equal, but Tom is more massive, so the acceleration of Tom will be less than the acceleration of Tracy because he's more massive. Okay, now once I have the acceleration, it asks what is Tracy's final speed after this contact? Well, I can find V final is equal to V initial plus acceleration of Tracy. Again, the time of contact is the time that she's accelerating. Okay, so we found this previously in this kinematics equation. This is given, this is 0, then this is the final velocity of Tracy. And I think that we're good to go on this problem.